Welcome back again. So continuing from the previous video and continuing from into the next discussion, we are supposed to actually solve this numerical or solve this status. What we have to solve for? We have to solve for the distances of this, and finally this. The distance from the datum surface to those respective points on the ground. Mind you, the distances are always calculated till the ground surface, not till the this levels. Okay, so our target is to actually find out the whereabouts of the ground and to actually the determine the location of the ground, the topography of the ground. That is our main point of concern, not anything else. So as per, we will discuss these things. So as you can see over here, we have sorted the observation. Now it is our time to actually sort it in two different ways. Now, how do you actually sort this numerical? This numerical can be sorted, or rather, this set of observation can actually be sorted in two different ways. One we call it as height of instrument method, and the second one we call it as rise and fall method. I'll write down the spellings for you. So we have a height of instrument method in this case. Height of instrument. Do not worry, if we do not have space over here, I'll again frame it somewhere over here so that we can separately solve the rise and fall method. Now what do you need to do over here is you just have to find out the height of instrument and you have to sort it as per. Now it's a typical thing. What is the height of instrument? Suppose I say, what is your height? How will you determine how much is your height? Say for example, my height, Professor Swinjay Roy, my height is basically 5 feet 11 inches. Now, where did I measure it from? There has to be a reference point. Now, I measured it from a ground surface, from the bottom of the hill till the top of my head. I have measured it and it is actually 5 feet 11 inches for your information. But if you look closely at this figure or at this figure, you can see these legs are differently placed at different levels. This is much more stretched leg, this is medium stretch, and this is the least stretched. If I measure the height of this from the ground surface, the same instrument is actually recording three different heights, which is very controversial. And that is the reason why we actually do not advise or we do not suggest to take the height from the ground, but we actually refer it from the datum surface. That is the thumb rule. We always have to calculate the height from this. Now, how much is the height? It is basically the height of, or the distance, the vertical distance from the datum surface. Height of instrument is basically the vertical distance from the datum surface till the line of collimation. This vertical distance I'm talking about. Now for this setup, you have this as the height of instrument, but for this setup, you have a different height of instrument. You can see. So height of instrument actually changes with the change in setup of the dumpy level or the auto level. In this case, we have these two different scenarios. One set of data is basically this, and the another set of data is basically this. So we will have different height of instruments at different points for different setups. So we'll come back to it, no issues. Now what we have to do is we have to write down the height of instrument. Shortened mostly as HI. We have to determine the height of instrument, and as per our final task, we have to determine the RL. Now, if you look closely, station 1 already has an RL. Can you see? It's 100 meters, right? So station 1 is already known and we already have a known data. That is the beauty of station 1. That is the beauty of uh, benchmark. I'm sorry. Now, if I extend it for your ease of understanding which one refers to what, this is it. Now, what is the height of instrument for this? I told you it is the difference between this surface and this one, the vertical difference. We have many such different values, right? Consider this setup only. We have a 1 meter distance over here, we have a 3 meter distance over here, we have a 2 meter distance over here. But these are only till the ground surface. We need the other ones also. As you can see, already this one is known from some previous study. This one is 100 meters and this one is 2 meters. So can I say that the height of instrument is nothing but 2 meters plus 100 meters? Yes, we can say it. That is basically what we need. The distance between this line and this line. And make no mistake, this is 102 meters, as we can see from the calculations. So height of instrument is nothing but the RL of benchmark plus the backside, which is 100 plus 2, which is 102 meter. As simple as that. And it is constant for this setup of readings. You come here over here, still the line of collimation remains at the same location and the datum surface remains at the same location. So basically height of instrument is constant for this setup. I told you also. This is already sorted. Now what for station number 2? Station number 2, what is the height of instrument at this point? Again the same thing from here to here. Isn't it the same as this? Because we did not change the position of the instrument. The instrument is wherever it was. So this entire distance is how much? Again 100 plus 2 meters or 102 meters right over here. This entire distance is 102 meters. Of this entire 102 meters, you have only this much as 3 meter. So what is the remaining distance? Plain simple 4-5 level mathematics. 102, the entire thing, minus this one. So 102 minus 3 will be nothing but 97 meters. So this one will be found out. I'll do the calculations for you, don't worry. This one is just now found out. So the height of instrument remains as it is. So what is the new RL over here? The new RL is nothing but the old RL sorry, I'm very sorry. The HI minus site readings. How much is it? HI is 102 minus site reading. See over here the site reading is intermediate site. For this line whatever is the site reading. For this line whatever is the site reading. And we have right over here as 97 meter. I'm telling you 102 minus 3. Sorry, I'm very sorry, it's 99 meter. Sometimes it happens. Sometimes it happens that we get confused with the numbers, but don't worry, we have rectified it. It's not about how we fall, but how we pick ourselves up. So this RL is right now known to be as 99 meters. If I apologize to my viewers if I have already referred to as previously as 97 meters. I'm correcting this time. It is 99 meters, and this is the final result. Now, next comes the station number 3, the most controversial station. At the station number 3, you will see that there are two different site readings. But we are not done with the first setup. So we will complete the first setup and then we will actually go for the second one. This is the second one. This is the first one. Until unless we complete one setup, we cannot go to the next one. So 2, 3 and 1. We have to complete 1 and then we have to move to 5. So we have to complete this and then we have to move over here. So how much is the height of instrument in this case? 102 meter. And how much will be the RL over here? I told you it is this RL, whatever height of instrument, whatever you have. What is the height of instrument for this setup? It's again 102 meter minus the side distance. Now you have two side distances. I told you once you have to complete and then you have to move from here. So this is the first thing which you have to consider. 102 minus side reading will be how much? 101 meter. 102 minus 1 is nothing but 101 meter. I hope I am clear to all of you. So we are done with the third one. Now here comes the most tricky part of height of instrument when you are changing the station. This point is basically that point which has a change of shifting of the instrument. Around this point, the instrument has been shifted like this. So this point is known as a change point. I'm highlighting this for you so that you do not forget the speciality of this. It's known as change point. I'm apologizing for my small handwriting, but then again, I have to keep it like this to accommodate all the things in a single page. So here comes the next one. Now you see, this height of instrument is done for the previous setup. Now there is a new setup at that point only, at station number 3 only we have a new setup. Now what is this new setup? I told you, what is the height of instrument? Height of instrument formula is always RL of BM plus backside. So do you have a benchmark or RL of BM at station number 3? Yes, you already have it, 101 meter. From the previous set of calculation, you already have it. And do you have a backside at station number 3? At station number 3? Yes, we do have it, 5 meters. And see, we have written it over here also, 5 meters. So isn't it, the height of instrument is nothing but the RL of benchmark plus the backside, the new height of instrument. This will be RL of benchmark plus backside is equal to 101 plus 5 is equal to 106 meter. There you go. This is the new set of or new height of instrument. As you can see also, to verify, this one was 102 meters and this one is 106 meters. Obviously it is larger than 102 meters, so we are actually going the right direction. And there you complete the third station. Third station is totally sorted. Now it's time to look from here till here. By the way, I did not write how much is it. This is 101 meter. Now we are about to go from this tricky station to another normal station, which is station number 4. Station number 4. What is the height of instrument at station number 4? The new height of instrument, this line from this line, and we have just now calculated, which is this, nothing but this, 106 meters. So height of instrument is again 106 meter for the new set. So how much is the RL? I told you RL is nothing but height of instrument minus the sight reading at that point. The height of instrument is 106 minus whatever sight reading you have. You do not have a backside at this. You do not have a foresight at this. You only have an intermediate sight. Whatever it is after all a sight reading. So 106 minus 4 will be how much? It's 102. So we have sorted this distance. See, slowly we are actually we have actually figured out this distance, RL of this point, RL of this point, RL of this point, and we are confident that we will actually sort these ones also. Just we have to be patient enough and we have to be, focused enough. That's it. At station number 5, I think you are already imagining that this is the station number 5 and this is where the RL needs to be found out. At this point, did we change the station? No, we just changed the direction of our viewpoint, but we did not change the location of the dumpy level. We did not change the location of this. So at the same setup, the height of instrument remains the same. The distance from this distance. And how much is it? The same old 106 meter. And what will be the RL of this point? Same formulation. Height of instrument minus the sight reading. Height of instrument is 106 minus the only sight reading available over here, which is 2. So 106 minus 2 is 104 meter. See, we are continuously sorting these things out. 104 meter. And we are actually winding up our discussion for this at station number 6. At station number 6, again, the instrument did not change, so the line of sight remains as it is, a line of collimation remains as it is. So the difference between the datum surface and the line of collimation will also remain the same. So this will actually continue. So again, we have 106 meter. And again, from the same old formulation, how much we have? 106 minus height of instrument minus the sight reading. Height of instrument minus the sight reading. Only sight reading available over here is 1. There you go. 105 meters. Basically, we have sorted and we have noted down, we have calculated all the RLs of this point. Sorry for my English, sometimes due to my excitement and sometimes due to my passion, I often speak some wrong English, but then again, English should not be the medium of any judgment. It is just a language. I hope that I made myself clear to my viewers with this discussion. This is how you sort the relative level and the reduced level calculations on the ground surface with height of instrument method. Next video, we are going to discuss how the same thing can be achieved with the help of rise and fall method. So we will meet again in the next video. Thank you so much for being patient and for your kind recognition.